This video provides detailed answers to questions from the Cambridge IGCSE Paper 2 Multiple Choice Extended, May-June 2024. I hope you'll find it useful in helping you prepare for future exams. In addition, on this channel, I have prepared lessons on each subject. Happy studying! Thank you in advance for watching this video. If you like it, please like, subscribe to the channel, share the video and activate the bell icon. This is very important for the continuity of this channel. Question 1. In which row are quantities correctly categorized into scalar quantities and vector quantities? In row A, mass and energy are scalars, while weight and acceleration are vectors, making this the correct categorization. Question 2. Which name is given to the quantity of matter in an object? The quantity of matter in an object is called its mass. Question 3. A body is moved from place X to place Y where the gravitational field strength is different. What happens to its mass and to its weight due to the move? When the gravitational field strength varies, the gravitational acceleration also varies. So the body's weight will vary, not its mass. Question 4. The mass of an object is 2.5 kilograms. The volume of the object is 480 centimeters cubed. What is the density of the object? Density is defined as mass divided by volume. It is necessary to convert mass to grams because the options provided for density are in grams per cubic centimeters. Question 5. 4 objects each have 2 forces acting on them. Which object is in equilibrium? In figures C and D, the applied forces are equal but do not act in opposite directions. Therefore, the objects are not in equilibrium. In figure B, the forces cancel each other out, resulting in translational equilibrium. However, rotational equilibrium is not achieved. In figure A, the forces applied are equal and opposite to each other. The forces cancel each other out, bringing the body to equilibrium. Question 6. A ball of mass m falls vertically and hits a hard surface. Its speed on hitting the surface is v1. It rebounds vertically upwards with the speed v2. What is the change in momentum of the ball? The change in momentum of an object can be calculated using the formula. Change in momentum equals final momentum minus initial momentum. For a ball, the initial momentum before it hits the surface is the product of its mass and the velocity, v1. After rebounding, the final momentum of the ball is the product of its mass and the negative velocity, minus v2, since this direction is opposite to that of v1. Therefore, the change in momentum of the ball can be expressed as follows. The negative sign in the equation indicates that the momentum is directed upward after the bounce. Question 7. A stone is dropped from a tall tower and falls a distance of 50 meters to the ground. The stone has a mass of 3 kilograms. At which speed does the stone hit the ground? When the stone is dropped, its initial speed is 0. The only acceleration acting on it is due to gravity, which is approximately 9.8. The distance the stone falls is 50 meters. To find the stone's final speed as it hits the ground, you can use Torricelli's formula. This formula allows you to calculate the final speed of an object under constant acceleration without needing to know the time interval. By substituting the appropriate values into this equation, you can solve for the final speed. Question 8. A coal-fired power station generates electricity. Coal is burned and the energy released is used to boil water. The steam from the water makes the generator move and this produces electricity. Which row gives the name of the energy store in the coal and the energy store of the moving generator? When coal is burned, the chemical bonds within its molecules are broken, releasing energy in the form of heat. The energy stored in coal is known as chemical energy. As the water boils, the steam produced causes the generator to move, transforming the steam's energy into kinetic energy, which is the energy of motion. Question 9. A man puts some ice into a glass of water on a warm day. After a short time, he noticed that the ice disappears and that water droplets appear on the outside of the glass. Which two changes of state are taking place? Water droplets form on the outer surface of a glass filled with ice water due to condensation, while the ice melts away. Question 10. Gas of volume 200 cubic centimeters is trapped inside a container by a piston. The piston is pushed to the right and the volume of the gas decreases to 100 cubic centimeters. The temperature of the gas remains constant. Which row states the effect that this has on the kinetic energy of the gas particles and the force per unit area exerted by the particles colliding with the inside walls of the container? To solve this problem, we can apply Boyle's law, which states that for a given mass of gas at a constant temperature, the product of pressure and volume remains constant. This means that when a gas occupies a larger volume, it exerts a lower pressure, and when it occupies a smaller volume, it exerts a higher pressure. Therefore, pressure and volume are inversely proportional. If the temperature stays the same, the kinetic energy of the gas particles does not change. Question 11. Which graph shows the relationship between the pressure and volume of a fixed mass of gas at constant temperature? Boyle's law explains the relationship between the pressure and volume of a fixed amount of gas at a constant temperature. It states that pressure is inversely proportional to volume. As volume decreases, pressure increases, and vice versa. This relationship is represented by a hyperbola on a graph. Question 12. During evaporation of a liquid, the most energetic particles escape. The temperature of the remaining liquid changes. Which row identifies where these particles escape from and describes the temperature change? During evaporation, the molecules with the highest kinetic energy are the ones that escape from the liquid surface and become gas molecules. As these high-energy molecules leave, the average kinetic energy of the remaining liquid molecules decreases. Since temperature is a measure of the average kinetic energy of molecules, the temperature of the remaining liquid also decreases. Question 13. Wet clothes are put out on a line to allow the water in the clothes to evaporate. Which type of weather would cause the water to evaporate most quickly? When temperatures are higher, water molecules gain more energy, allowing them to escape from the fabric and evaporate. Low humidity, which means there is less moisture on the air, enables the air to absorb more water vapor, thereby promoting faster drying. Additionally, wind helps to carry away the evaporated water vapor, replacing it with drier air, which further accelerates the drying process. Question 15. A solar water heater is designed to absorb energy from sunlight. Which surface texture and color would be best for the solar water heater? Black absorbs nearly all visible light wavelengths, converting more solar energy into heat. In contrast, lighter color like white reflect a significant portion of sunlight, which reduces energy absorption. Question 16. Which statement about waves is correct? Waves are disturbances that transport energy and momentum without moving matter. Question 17. The angle of incidence of a ray of light incident on a plane mirror is gradually increased. To the nearest degree, what is the maximum possible angle between the incident and the reflected rays? The angle of incidence is equal to the angle of reflection. The angle of incidence can reach a maximum of 90 degrees. Consequently, the angle of reflection is also 90 degrees. Therefore, the angle between the incident ray and the reflected ray can be as much as 180 degrees. Question 18. Which conditions are necessary for light to be totally internally reflected? For total internal reflection to occur, light must travel from a denser medium to a less dense medium, and the angle of incidence must exceed the critical angle. Question 19. The diagram shows a ray of light passing from air into a transparent substance. What is the refractive index of the transparent substance? Snell's law relates the angles of incidence and refraction to the refractive indices of the two media. The refractive index of air is approximately 1. You can rearrange Snell's law to solve for the refractive index of the transparent substance, N2. Question 20. The diagram shows a ray of light passing from air into a transparent substance. Which statement correctly explains the condition for the maximum transmission of light by the optical fiber? In an optical fiber, there are two main components, the core and the cladding. When light travels through the core, it interacts with the atoms of the medium, which causes the light to slow down. As a result, the core has a higher refractive index than the cladding. This difference in refractive indices allows light to be guided through the core using total internal reflection. Question 21. Which region of the electromagnetic spectrum is used for detecting fake banknotes? Genuine banknotes often incorporate fluorescent inks, security threads, or watermarks that become visible or exhibit unique characteristics under UV light. Question 22. A sound wave travels at 330 meters per second. The distance between the center of a compression and the center of the nearest rarefaction in the sound wave is 2.5 centimeters. What is the frequency of the sound wave? Sound waves are classified as longitudinal waves, which means that the vibrations of the medium, such as air, occur in the same direction as the wave travels. In this type of wave, the particles of the medium oscillate back and forth, creating areas of compression, where particles are close together, and rarefaction, where particles are spread apart. The distance between a compression and the following rarefaction is half the wavelength. In this case, the wavelength of the sound wave can be calculated as 2 times 2.5 centimeters, resulting in a total wavelength of 5 centimeters, equal to 0.05 meters. The speed of a wave is related to its frequency and wavelength by the equation speed equals frequency times wavelength. By solving for the frequency, we can find the requested answer. Question 23. Which waves are used in the medical scanning of soft tissue? Medical scanning of soft tissue primarily utilizes high-frequency sound waves, ultrasound. Question 24. Which rule describes suitable materials for using a temporary magnet and in a permanent magnet? Soft iron is suitable for temporary magnets because it quickly loses its magnetism when removing the external magnetic field. On the other hand, steel is suitable for permanent magnets as it retains its magnetism even after the external field is gone. Row B clearly illustrates this with soft iron as a temporary magnet and steel as a permanent magnet. Question 25. A magnetic field is represented in the diagram by magnetic field lines. At which point is the magnetic field strongest? Magnetic field lines visually represent the magnetic field's direction and strength. The closer the lines are, the stronger the field. In the diagram, the concentration of lines at point A indicates a stronger magnetic field there. Question 26. A student determines the resistance of a resistor R. She uses a circuit including a voltmeter and an ammeter. Which circuit does she use? For accurate measurements, connect the voltmeter in parallel with the resistor to measure voltage and the ammeter in series to measure current. Circuit D is correct as it properly connects the voltmeter in parallel and the ammeter in series with the resistor. Question 27. A diode and a resistor are connected across a variable DC supply. Terminal X is initially positive and at a maximum value. The potential difference across XY is adjusted so that it changes as shown by the graph, which graph shows how the current in the circuit from X to Y varies during the same time interval. A diode acts like a one-way valve for electricity. It lets current flow easily in one direction, forward bias, but blocks in the opposite direction, reverse bias. The graph shows the voltage across XY decreasing. Initially, the diode is forward biased, allowing current to flow. As the voltage drops, the diode transitions to reverse bias, and the current flow through the circuit rapidly decreases to zero. Graph D perfectly illustrates this behavior. Question 28. When a conductor in a complete circuit cuts across a magnetic field, a current is induced in the conductor. Which statement about the induced current is correct? Item D describes Lenz's law. Lenz's law is a fundamental principle of electromagnetic induction. It states that the direction of the induced current in a circuit opposes the change in magnetic flux that produces it. Question 29. The diagram shows a solenoid carrying an electric current. Which row compares the strength of the magnetic field due to the second solenoid at points Y and Z with the strength of the magnetic field at point X? The magnetic field inside a solenoid is relatively uniform and stronger than the field outside the solenoid. Points X and Y are inside the solenoid, which means that the magnetic field strength at point Y is equal to the magnetic field strength at point X. In contrast, point Z is outside the solenoid, so the magnetic field strength at point Z is weaker than the magnetic field strength at point X. Question 30. A conducting wire is placed between the poles of a magnet. When an electric current in the wire is in the direction shown, then the force on the wire acts out of the page. Three statements of different conditions and how the wire is affected are given. Which statements are correct? This question describes a conducting wire positioned between the poles of a magnet with an electric current flowing through it. The direction of the magnetic force can be determined using the right-hand rule. To apply the rule, point your thumb in the direction of the current. Then, orient your fingers in the direction of the magnetic field. The direction of the magnetic force is indicated by a line that extends perpendicularly from your palm. Let's analyze which statements are accurate. Look at the drawing according to the first statement. Since the magnetic field lines run from left to right and the current flows upward, the resulting force will be directed into the page. The first statement is true. Look at the drawing according to the second statement. Since the magnetic field lines run from right to left and the current flows downward, The resulting force will be directed into the page. The second statement is true. Based on our conclusions regarding the above statements, when the current in the wire alternates, the wire vibrates into and out of the page because the direction of the magnetic force also alternates. The third statement is true. Question 31. Which types of electric current are in the primary coil and the secondary coil of a step-up transformer? When a transformer works, a primary voltage drives an alternating current through the primary coil. The primary coil current produces a changing magnetic field. This magnetic field changes as the current changes. The iron core is easily magnetized and carries the changing magnetic field from the primary coil to link the secondary coil. Alternating voltage is induced in the secondary coil. The induced voltage causes an alternating current to flow. Therefore, both the primary and secondary coils of a step-up transformer must use alternating current. Question 32. A scientist fires alpha particles at a very thin sheet of gold and detects the particles that pass through. Which statement about the results of the scattering experiment is correct? In Rutherford's gold foil experiment, most alpha particles passed straight through the thin gold foil, while a small number were deflected at large angles. This suggests a small, dense, positively charged nucleus at the center of the atom. Question 33. The notation represents the nucleus of a gold atom. The relative charge on a proton is +1. What is the relative charge on the gold nucleus? In atomic notation, the atomic mass is on the top left of the elemental symbol, and the atomic number is on the bottom left. For gold, this indicates 197 particles in its nucleus, consisting of 79 protons and 118 neutrons. The total charge from the protons is plus 79, as each proton has a charge of +1. Question 34. An isotope of hydrogen has the nuclide notation. How many neutrons are in the nucleus of this isotope, and what is the relative charge on the nucleus? This exercise is almost the same as the previous one. The number of protons is the atomic number, and the number of neutrons is the mass number minus the number of protons. The nucleus of the hydrogen isotope has 1 neutron and a relative charge of +1. Question 35. A radioactive source is placed near a detector. The radiation arriving at the detector from the source is measured for 10 minutes, with different materials placed between the source and the detector. Which types of radiation are emitted by the source? To identify the types of radiation emitted by a radioactive source, we can analyze how different materials affect the radiation detected. When paper is used, the count remains nearly the same. indicating that alpha particles are absent since they would be blocked. With aluminum, the count drops significantly, suggesting the presence of beta particles, which aluminum can stop. Finally, when lead is used, the count decreases further, indicating gamma rays, which lead can attenuate. In conclusion, the radioactive source emits beta particle and gamma rays. Question 36. The reading on a detector placed near a radioactive material is 536 counts per second. The background count rate is 44 counts per second. The half-life of the radioactive material is 34 hours. What is the reading on the detector after 68 hours? To begin, calculate the number of half-lives by dividing the total elapsed time by the half-life. Next, determine the initial count rate of the radioactive material by subtracting the background count rate from the initial reading. After that, calculate the count rate of the radioactive material after 2 half-lives, and then add the background count rate to this count rate. Question 37. A planet in the solar system is at the point in its orbit where it is closest to the Sun. Which row is correct? In our solar system, 2 key points in a planet's orbit are the perihelion and the aphelion. The perihelion is where the planet is closest to the Sun, resulting in the highest velocity and kinetic energy, but the lowest potential energy. Conversely, the aphelion is where the planet is farthest from the Sun, leading to the lowest velocity and kinetic energy, but the highest potential energy. As a planet moves from aphelion to perihelion, its gravitational potential energy decreases, while its kinetic energy increases, ensuring that the total energy remains constant in a closed system. Question 38. What is the main process that powers the Sun? In the core of the Sun, extremely high temperatures and pressures cause hydrogen atoms to collide with sufficient force to overcome their electrostatic repulsion and fuse together. This fusion process converts hydrogen into helium, releasing energy in the form of photons and neutrinos. Question 39. A galaxy is 3 times 10 to 20 kilometers from the Earth. At which speed is the galaxy moving away from the Earth? To solve this exercise, you must apply Hubble's law. This law states that the Hubble constant is equal to the speed of an object moving away from an observer. This speed is also known as a recession speed, divided by the distance between the object and the Earth. Solving this equation for speed, you get the speed at which the galaxy is moving away from the Earth. Question 40. An astronomer observes a distant galaxy. The table shows how the distance and the speed of recession of the galaxy are determined. Which row is correct? A galaxy's recessional speed is typically determined by measuring its redshift. Redshift is a change in the wavelength of light, where the wavelength increases, shifts towards the red end of the spectrum. Measuring the intrinsic brightness of a supernova or other kinds of standard candles, such as the Cepheid variable, allows astronomers to calculate the distance to the standard candle's home galaxy.